Hello everyone, today Natasha and I will prove an interesting property of regular languages, that when you take a regular language and reverse all its strings, you still get a regular language. Proving it requires a clever construction that we'll walk you through together. So let's actually start by understanding exactly what we are trying to prove. So we begin with any DFA-M, and this accepts some regular language. For every string this DFA accepts, we want to take its reverse. So for example, if our DSA would accept 10110, we want 01101. We need to prove that this new set of reversed strings is also a regular language. And in mathematical notation, we write this as in the formally equation, where LM, it denotes our original language, W raised to power R, that denotes, so it means that if we're talking about the reverse of string W. So now our key question is, does this reversal operation preserve regularity? And we'll prove this using a constructive approach. So instead of just claiming the reversed language is regular, we'll actually show how to build a machine that would accept it. Specifically, we'll take our original DFA and convert it into NFA. This new NFA will accept exactly the reversed strings. Since we know that NFAs can accept regular languages, this will prove our point. And the beauty of this approach is that it not only proves the result, but also gives us a method to actually construct the machine for that given DSA. So now we have is the construction of M prime. Now here's the clever part, how we build our NFA M prime. So we start with our original DFA M, which has Q, sigma, delta, Q0, F. And the first key idea is to add a new state S0. This will help us handle multiple accepting states in the original DFA. And then the second key idea is to reverse all the transitions. So if a state starts with A, went to B with input 0 in the DFA, now B goes to A with input 0 in NFA. And the third key idea is we add epsilon transitions from S0 to all accepting states of the original DFA. And this lets us start from any state where the original DFA might have accepted. And finally, we make the original state Q0 our only accepting state. And this is because if we are reading the string backwards, we should end where the DFA started. So the formal notation for our NFA would be M prime equals Q union set of S0, sigma delta prime S0 and set of Q0. So Q union S0 means we keep all the original states plus our new S0.
We came up with a couple of examples to put the construction into perspective. For the first example, we have a DFA that accepts the string 10110, and beside it is the path the string follows. So it would follow the path Q0, Q1, Q2, Q0, Q1, Q2. And then when constructing the reverse NFA, we add the SO to help us in navigating the accept states by the E transition that will let the NFA jump into any accepting state in the original DFA. And so in this case, the accepting state in the DFA was Q2, so S0 would jump to Q2. And then the transitions also reverse from the original DFA. So for example, Q0 to Q1 through 1 would be Q1 to Q0 through 1, and so on and so forth for all the different states. And reversing the same string that we had would be 01101, and then the path it would follow is Q2, Q1, Q0, Q0, Q1, Q0, which is the exact reverse of the path that we used in the DFA. In the extended example, we used two accepting states for it, which is Q2 and Q3, and as an example we used 0, 1, 1, 1, 0, 1, 0 as the string to show that the reverse would also be a regular language. Then the path followed by the DFA was Q0, Q0, Q1, Q3, Q3, Q0, Q1, Q2. And then when it came to constructing the NFA, the Q0 will always be the accept state, because in a DFA we always start from Q0, and so it would only make sense that the reverse of the string in the DFA would end in Q0 in the reversed NFA. And then the same thing we did for the transitions in the previous example is what we do here pretty much. Just reverse the transitions, and in some strings you would notice, for example in this case Q2, at the start of the NFA, 0 could either loop through Q2 again or go to Q1. Since we're trying to prove that they are the reverse of each other, we're going to ignore the path that would loop through Q2 again for it to make sense, and take the Q1 path. So eventually the reverse would be 0, 1, 0, 1, 1, 1, 0, and the path would be Q2, Q1, Q0, Q3, Q3, Q1, Q0, Q0, and that's the reverse of the original path in the DFA. Yeah. In conclusion, as illustrated in the proof and as per the examples we gave, we see that when a string is accepted in the DFA, its reverse will also be accepted in its reversed NFA. And so it's only fair for us to say that an NFA M prime accepts a set of all strings in M but reversed. And so if the language is regular, so is its reversed. And then the key takeaway is that regular languages are closed under reversal.